Last week you guys did this lab on acceleration and time and collecting the data for the graphs, and then there was a few homework questions that I wanted to run through. And this one is about identifying the motion in these position time or distance time graphs. Okay, and so I messed up and I've got A's and B's interchanged with 1's and 2's, but I think you figure it out. So the following graphs are made by carts moving in front of a motion detector. Assume that the detector is at the origin. A. What is the sign of the acceleration of the cart that is speeding up, moving away from the detector? Now, hopefully you guys remember that acceleration doesn't show me the direction an object moves, it doesn't show me the position an object is at, and it really doesn't even tell me if the object is speeding up or slowing down. Positive acceleration means that the final velocity is more positive than the initial velocity, and negative acceleration means the final velocity is more negative than the initial velocity. Okay, but if it's going to be speeding up, moving away, then we know two things. We know that it's getting faster, so that's positive. We know it's moving away, that's positive, and two positives make a positive. Which graph would the cart in part A produce? Well, part A says speed up, move away, and we gotta go up to these graphs and see which one is speed up, move away. These are all xt graphs. D is for distance or displacement, and we'll just go with position for now. Okay, so this one shows that it moves away at a constant rate. This one shows something going on, but it's not speeding up, moving away. This one, graph 3, does show speed up, move away, and we can tell the curve gets steeper. Okay, and that basically tells us curve gets steeper and the slope is positive, right? And that tells us it's getting faster and moving away. Which graph was produced by a cart moving at constant speed? That would be graph 1. We can tell because it's a constant velocity, constant slope, constant velocity, which means the velocity isn't changing, no acceleration. Which direction is the cart in graph 3 moving? Well, we've already said it's away. Okay, we can tell because it gets further away from the origin. Is the cart in figure B, it says figure B, it means graph 2, okay, ever speeding up? In fact, it is. Okay, if we split this graph in half, okay, speed up means that the line needs to get steeper, and it gets steeper, gets steeper, gets steeper. Right here we have this point where it changes what it's doing. It gets less steep, less steep, less steep. This is called an inflection point, okay, and it's where a graph changes concavity. A graph can be concave up or concave down. A concave up graph would hold water. A concave down graph would shed water. Okay, so yes, we've indicated that. It also is slowing down in the other region, right? It goes from steep to less steep. All right, and then this last part here basically summarizes the relationship between velocity, position, and acceleration. Okay? If the car's moving away from the origin, it's moving in a positive direction. If it moves towards the origin, it's a negative. If it's moving away from the origin, that's a positive velocity. If it's moving towards the origin, that's a negative velocity. If it is moving away, speeding up, that's positive. If it's moving away, slowing down, that's negative. If it's towards the origin, speeding up, okay, that's negative. And if it's slowing down, that's positive. All right, so then let's take a look at a couple of these graphs and see if we can answer these questions. Describe how you would move to produce the velocity time graph on the right. The description should be in terms of speeding up or slowing down, moving away from or towards the detector. We have two time intervals. It looks like one, but we got to remember on a velocity time graph, this shows us a change in direction. So from 0 to 5 seconds, we started really, really fast at 2 meters per second and got slower all the way down to 0. So slow down. And which direction are we moving? Well, it's a positive velocity, so we're moving away. 5 to 10. It starts at 0 meters per second, ends up down here at -2 meters per second. So it actually got faster, but it changed direction. Speed up, move towards. Okay. 9, sketch a distance time graph. Says distance means position. On the axis on the right, now you know you're saying, but I need to know a starting point. Well, we'll assume it started at 0. Okay, so right down here, here's our starting point. 5 seconds later, we need to know how far it's gone. Well, 2 times 5 is 10, right? I'm finding area, 1/2 base times height. So 2 times 5 is 10, times a half is 5. So it needs to have gone 5 and 5. 1, 2, 3, 1, 2, 3. Oh, that's above where I could go. So I'm going to go 2, 4, 5. All right. And while it's doing this, it started fast and got slower, so that line needs to curve, be concave down. Here it starts slow and gets faster, but it comes back those 5 meters in 10 seconds. So it should look like this, fairly symmetric. The whole thing is concave down. Alright, number 10, sketch an acceleration time graph. Well, the whole time the slope of the velocity time graph is negative. Okay? And so every time we look at this, the ending velocity is more negative than the starting velocity, so that tells us a negative acceleration. It's a straight line, not a curved line, so it's a constant negative acceleration. Right there looks good since our graph isn't scaled. Okay. A car can move in either direction in front of the motion detector. That's what positive x is. Sketch a velocity time graph and acceleration time graph for the following cases. The car starts from rest and moves away from the origin, increasing its speed at a constant rate. Starts from rest, so here's rest, moves away, it's got to be up here, increasing its speed at a constant rate. This slopes up. Acceleration is therefore constant and positive. 12, the car is moving towards the origin at a constant velocity. Towards means it's got to be a negative velocity. Constant means that the velocity doesn't change, so it's horizontal. And if the velocity isn't changing, the acceleration is 0. So that's just right along that axis. The car starts from rest and moves towards the origin, increasing its speed at a constant rate. Starts from rest towards the origin, getting faster, so it slopes down. That's a negative constant acceleration, or whatever I drew there. Let's try that again. Okay, so a negative constant acceleration. And since the graphs aren't scaled, we don't have to pay too much attention to it.